In the last video, I've used this resistivity formula to estimate the resistance of the copper wire connecting the light bulb and showed that the resistance of the copper wire is of this kind of value, is 0.0 something of an ohm, and so it is a lot smaller than the resistance of a typical light bulb, which is nearly 1,000 ohms. What I'd like to do now is to use this same formula that relates resistance to length and thickness of a wire to estimate the length of the tungsten filament in this filament lamp. Now I'm going to assume that this light bulb is a filament lamp made of tungsten filament, and there's a piece of tungsten wire inside that gets very hot when the current goes through it, and that it has this resistance of 881.7 ohms, which I determined in an earlier video, assuming this power rating. So let's try. Okay, so let's look at what we have. Okay, I'll start by clearing this product. And I'll write down what I want to find. I want to find the length of the tungsten filaments. Okay. Now, but before we even start, there is something very important that we must remember. We must remember from a few videos ago that the resistance of the light bulb increases by more than 10 times when it gets hot. When the light bulb starts glowing, when the filament lamp starts glowing, the temperature typically goes up to about 3,000 degrees Celsius, and at that temperature the resistance is much bigger than the value at room temperature. It is in fact this value, meaning that at room temperature it would be much smaller. Now, this value for the resistivity of tungsten is actually the value at room temperature. Okay, so this in brackets. This is actually the value at 25 degrees Celsius. Well, if that's the case, then what's the value at 3,000 degrees Celsius? Well, fortunately, the value of the resistivity of metals, in particular of tungsten, is well documented. It's something that we can also find on Google, and the value for, let me write this down, the value for the resistivity of tungsten at 3,000 degrees Celsius is 105 times 10 to the power of minus 8 ohm meter, same units. So if you compare with the value of 5.6 times 10 to the power minus 8 at room temperature, 105 is nearly 20 times bigger. It's nearly 20 times bigger. And So this is the value we need to use, 105, and not this. Okay. So let's press on. Now what I like to find is the length of the tungsten filament. I can use the same formula, but there is one more value that I need. If you look at this formula, we have the R. R is this 881.7 ohms. We have rho, the resistivity at 3000 degrees Celsius. L is what we want to find, but we don't know D yet. Right, so we need D. Now D is a value again that we can find on Google. If you Google, say, if you look up Wikipedia on filament lamp, you will find a typical value for D. Now D is typically a few tenths of a micrometer, so usually maybe between 30 to 50 micrometers. So I'm going to take as given that D is 40 micrometer. Okay, so remember that when we make use of this formula, we must convert this to SI units, and micro is 10 to the power minus 6. So I'll just write this down just to make sure that we get it right. This is 40 times 10 to the power minus 6 of a meter. So that's the value I would use. And L is what I want to find. So we have all the numbers now. We are ready to find L. So first, let me rearrange this formula to make L the subject. L is equal to, right, I would move the denominator over to the other side. So I'll have and the rho over here. So I have I have R over rho times rho down here times this lot, this denominator, which is the area of cross-sectional area of the filament. So times pi d over 2 squared, and we know all the values. So just to make sure, let me just trace the values to the numbers. So D, okay, D is here, right? D rho, let's say rho is there. That's rho, okay. All the way to here. Yes, that's rho. Okay, and we can put that into here. And R, let's see, R is here. R is the 881.7. Okay, so we definitely have all the numbers we need, all three numbers for R, rho, and D. So we're ready to type this into our calculator. Okay. And I did that, and the answer I got is 1.06 meter. It's 1.06 meter. Now, if you think about it, how long is 1.06 meter? If you stretch out your hand, if you stretch out your arm, 1.06 meter is maybe a little bit longer than the arm of most people. I think that's quite long. But if you think of a light bulb, if you have probably seen a light bulb before. If you think of a light bulb, the light bulb is something which you can hold in your hand, right? It's not likely to be a lot bigger than the size of your hand. And the filament is just looks like a tiny bit of wire in the middle of the light bulb. I mean, I'm talking about a simple filament light bulb of the kind where you have a clear glass, and you can look inside and you see a thin piece of filament wire. It doesn't look like much, but if you look more closely, what you'll find is that the filament is a coil of wire. Alright, there are many turns in the coil. Now, if you look even more closely, you'll find that in the coil, the wire in the coil is itself another coil. So I'll see if I can show you what I mean. Now, you might think that when you look at the wire, you see a coil right inside the glass bulb. You see a coil like that. But actually, if you look more closely, this wire is actually a coil in itself. And what I mean is this. The wire is actually like this. You have a tiny coil that is coiled round and round into a bigger coil. Not drawing this very well, but I hope you get the idea. So in other words, it is a coil that is made into a coil. Alright, so it's a coil within a coil. And there's a word, a term to describe this complicated arrangement. It is called a coiled coil. A coil. And because it is coil, there are so many turns in this coiled coil that you can actually squeeze a very long piece of filament into the filament. And that's how this 1.06 meter, which seems much longer than you would expect from the size of a light bulb, that's how it's possible to squeeze this 1 meter, and some light bulb might even have 2 meters, right, squeezed into this coil of the filaments in a filament lamp.